out for on Tuesday, in case you guys aren't here Monday. Hi, Waylon. Okay, yeah.
Where are you?
Voice off. Students were able to solve for missing variables. In equivalent expressions. Okay. You're on day 2. One more day of this, and then we'll CASP on Thursday or Tuesday. Yay! That's your reaction to casping.
That wasn't a cat meow.
Oh, I heard.
Okay.
Shut up. Oh my god.
Hey, stop. Think about this. Try to solve this problem like you did yesterday and see if it works. On the right side of this, you're going to set it up and try to solve it. Remember yesterday we were working on this thing and trying to get it as simple as possible so that we could match it. Can you do it this way? Try to solve it like we did yesterday. And in 20 seconds, I'm going to be trying to talk and give your partner either yes or no, we could solve it, or maybe we could, but it was harder. Turn and talk, go.
What is that equal?
Yeah.
To the left of the what is that?
Equal. 5, 4, 3, 2, 1. Colby, thoughts? So you could do this one, and how did you do it, Colby?
I did that 2 times 5 equals 10.
Okay, I'm going to pause you. So Colby is one step ahead, and if we tried to solve it yesterday, this is what would happen. We're getting t times 5x and t times 4. That becomes 5xt and 4t. When you distribute these types of problems on the test, Alan, and you're looking at that thing and going, I have 2 variables next to each other, it kind of looks like just odd and funky. You're going to stop, and we're going to reroute our method and use today's lesson as the solution. So we can't solve this really easily because there are 2 variables. Next, or in the same term. Let's use a math vocab word. 2 variables in the same term, 5xt looks weird. When you see that, you're going to stop and use what Colby was about to say, but I didn't want him to spoil it for you. So here's the steps. You're solving this like yesterday. Vienna, you can close it. And you distribute a variable, and it makes a double variable term. You're going to stop. And here's what you're doing. Colby was about to say this, but you're going to think, what would I multiply by the first number in parentheses that makes the other side true? Let's look at that same problem, Tony. It would, and that's what he was going for. And let's write this, and then we'll logically see that this just makes sense to be 2. I know, I need to make capital T's. Period 4 and 5 already yelled at me, so give me a break. There's a T, that's a plus sign, this is a plus sign, this is a T. It's just getting worse. So when you're doing this problem, notice how when you multiply it, it makes 5xt. But Colby said, well, you could just think, what times 5x is equal to the other term? Since 5x needs to match 10x somehow, what times 5x equals 10x? Dallin?
2.
And 2. So 2 would be your answer, and that would match. Do you technically have to see if 2 times 4 equals 8?
Yeah.
You kind of don't, because once one side matches, you know it automatically will make the other side true as well, since they've already told me it's equivalent. So when you're looking at these problems, you might see some numbers that have decimals, others have whole numbers. I would choose the one that's not a decimal and use that one. Example 2. Enter the value of p, so the expression 14 plus 7n is equivalent to p times 7 plus 3.5n. You see this on a test and you start to distribute to try to make it equal, but you end up with this funky looking term. You're going to stop. And Abby, what are you thinking instead? That works. Notice how the 3.5 is a decimal, so we're going to stay away from that one. 7 times 2 is 14, so p would equal 2. Okay, circle it. Those are the two easiest problems you'll see. Try this one in 30 seconds. Go. And raise your hand if you have the answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mackenzie, answer? N times 6 equals 24. So 4 times 6 works. Notice how 2 times 5 times 2.5 times 4 also equals 10. Stop. But this is just a little more complicated because it's a decimal. So I'm going to go with the easiest route and use the n times 6 and move on with my life. Example 3, slightly harder, very similar to what you did in the warm-up today. Select the value of p that would make the equation true. This time we have some fractions. And I noticed that p times 2n equals 2np. So double variable says to go back and rethink about this problem. What times 7 equals 7 over 6? Tanner.
1/6.
If you could not do that mentally, here's what you should be writing instead. What times 7 over 1 equals 7 over 6? And we're going to work left to right. 1 times 7 is 7, and 6 times 1 is 6, so 1/6 is my answer. Got it? Thumb up. Moving too fast? Give me a thumb down. Karen, Kingston, Chromebook closed. Colby, Chromebook. Jordan, Chromebook closed. Okay. Last example. This one's slightly different, but it matches what you did on Quizlet today. And because we practiced that, it should be pretty easy. It says to enter the number that makes the equation 0.76 plus 24 hundredths equals some mystery number over 100 plus 24 hundredths true. What can I cancel from Tuesday's lesson to make this equation easier? Elliot.
Can you cancel the 74 hundredths?
The 24 hundredths? Oh, you're looking at you try.
Sorry.
Go up to example 4. Yeah, because they happen on the same side of the equal sign, you're going to cross them out and rewrite this thing. Well, 0.76 is the equivalent to what fraction? Elliot.
7600.
Yeah, so when you rewrite it like this, well, what would the top number be? It would be Elliot.
76.
I hate you.
Oh, I thought it was 50.
It's 76
Why did
hundred
you say you made me?
because he was mocking me. Mhm.
No, Karen.
Try your try.
Look out. Don't forget your eggs in his fridge.
That's why they're right
They're
here.
right there. Yeah, I set 3 alarms.
You try. Go.
What if you're done?
Wait.
26.
Okay. The answer is 26 hundredths.
Second grade call and they want their math back.
Great. We looked at 3 problems today, you guys, or 3 different types of problems.